In the last video, I pointed my own QA toolkit at my own website, and it found 11 problems. This time, I'm going to fix the most critical ones. Then I'll hand everything back to the toolkit and ask it to verify my work. And here's where it gets interesting. One of those 11 findings turns out not to be a problem at all. That might actually be the most useful part of this video. Quick recap for anyone who hasn't seen part 1. The toolkit installed from an empty folder, explored my site, and produced this. 11 defects, prioritized, each one traced to the evidence it came from. 2 were critical. My robots file pointed search engines at a sitemap that didn't exist. And the show and hide password buttons on my sign-up page had no accessible name, so screen reader users couldn't tell what they did. Everything from here on is what happens after the finding. Filing it, fixing the defects, verifying the fix, and updating the final execution report. Findings in a document are easy to overlook. So let's move the identified defects into Jira. Our toolkit includes a Jira connector skill. To use it, simply provide your Jira API credentials and project details in the .env file. Alternatively, you can connect to Jira using the Atlassian Rovo MCP server, which the toolkit also supports. In GitHub Copilot chat, I enter the prompt, file D3 from the test report as a bug in Jira. After reviewing all the relevant files, notice what it does first. Before it composes a new Jira ticket, it performs a duplicate check to make sure the same defect hasn't already been reported. My project is new, so there's nothing to find, but that behavior is the point. On a real backlog, this is what stops the same bug being filed 3 times by 3 people. Next, it composes the ADF description for the Jira issue. Then it runs a dry run to validate the payload before creating anything. The dry run confirms that the payload is correct and that there are no required field errors. Before making any changes, the agent presents the draft in a readable format and asks for confirmation. It shows me exactly what it would send to Jira and waits. Nothing is written until I approve it. Only after confirmation, it will create the Jira issue, attach the accessibility audit findings as evidence, and update the report and CSV file with the new Jira key. I provide my confirmation, and it continues with the assigned task. And there's the ticket. It includes the summary, environment, steps to reproduce, expected and actual results, and the evidence it captured. This is the kind of ticket a developer can pick up and act on without needing to come back with additional questions. It also writes the Jira key back into my local report, which will become important in a few minutes. Next, I asked it to file defects D2, D4, and D5 as well. Just like last time, it first did a dry run for my review. Once I approved it, it went ahead and created 3 new Jira tickets. These tickets followed the same pattern as Defect 1, with all the necessary details included. It also assigned the right priority and appropriate labels to each ticket. And here's something important. After filing the tickets, it told me it had made a mistake. The first ticket was created without a priority, so Jira defaulted it to medium. But this was actually a critical defect. It also explained that it couldn't fix the issue because the connector didn't have a way to update an existing ticket. Instead, it offered to leave a comment for a human to fix it. There are 2 things I want to point out here. First, it caught its own mistake and told me about it. I didn't have to discover a critical defect sitting in the queue with a medium priority. Second, it clearly told me what it couldn't do instead of trying to guess or make up a workaround. I immediately fixed the defect priority. I also shipped the missing capability that same afternoon. The connector can now edit existing Jira issues, and the skill that files bugs always sets the priority. That's the kind of feedback loop I want from a tool I depend on. It tells me where it falls short, and then I fix the gap. Now comes the actual work for defect fixes. The sitemap was the quickest one. My site wasn't generating a sitemap at all, but the robots file was pointing to a page that didn't exist. In next.js, that's just a single file to add. Next, the password toggles needed accessible names. That way, a screen reader can announce show password instead of leaving the control unlabeled. The color contrast was a near miss, not a redesign. My header text had a contrast ratio of 4.36 to 1 against the background, just below the required 4.5. Simply darkening the orange slightly brought it up to 6 to 1. And visually, nobody looking at the site would notice the difference. And finally, the metadata. Every page on my site was using the same title and description. There were also no canonical tags and no open graph tags. The fix was a single change to the root layout, and it fixed everything at once. That's why grouping findings by root cause matters more than simply counting them. Now the interesting one. One finding said the login and sign-up pages had no visible focus indicator. If you navigate by keyboard, you wouldn't be able to see which field you were on. That's a real accessibility failure when it's true. I went to fix it, and I could plainly see an orange ring around the focused field. So I checked properly, and the finding was wrong. Here's why, because the reason is worth understanding. The check read the page's computed styles after focusing an element programmatically. But programmatic focus does not reliably trigger the browser state that makes a modern focus ring appear. My site builds its ring from CSS variables, which sit empty until that state is active. The tool measured a ring that hadn't been asked to appear yet and correctly reported that it saw nothing. I fixed the skill the same day. It can no longer report a focus problem from computed styles at all. It has to press tab for real and compare a screenshot of the focused element against an unfocused one. I'm showing you this because it answers an important question about any AI testing tool. The question isn't just, is it right? Instead ask, what happens when it's wrong? Here, a human caught the mistake in about 30 seconds, and the tool was improved so it wouldn't make the same mistake again. That's not a failure. That's a workflow. Now it's time to verify the fixes. I'm not going to tell you the fixes worked. I'm going to have the toolkit check. 3 of the 4 have recorded reproduction steps it can rerun, so those are the ones I'll name. The metadata fix I'd already confirmed by hand, because you can see it in any browser by looking at the page source. Here's my prompt. Re-verify D2, D3, and D4 against the current site. Skip D5, I closed it as invalid, and leave the rest for now. It takes each recorded reproduction step, runs it again against the live site, and gives us a verdict for each one. It's not my opinion, and it's not a developer saying, yeah, that's done. It's an actual verification. For the sitemap, it confirmed the file now returns a 200, that the XML is valid, that it lists 142 URLs, and then it sampled 6 of those at random and checked they all resolve. For the other 2, it reran the same accessibility scan and confirmed the specific rules that were failing no longer fire. Then it found something I wasn't expecting. While rechecking the contrast fix, it found new contrast failures. A button on the home page, some links on sign up, the price badges on the courses page. Different components, different colors, nothing to do with the header navigation I'd just fixed. And here's the part one want to highlight. It did not reopen the original defect. It logged the new failures as a separate item and left the original closed because the original was about the header navigation and the header navigation is genuinely fixed. That distinction sounds small, and it isn't. If a tool treats a similar problem somewhere else as the same problem, your fix looks like it failed, the ticket never closes, and after a few rounds of that, nobody trusts the defect report. Keeping them separate is what makes the record worth having. This is the loop that closes. A finding became a ticket, the ticket became a fix, and the fix was verified independently against the original reproduction steps. Nothing here depended on anyone remembering what the bug was. The rest of the findings are still open, and I'm leaving them that way for now. They're lower severity, and that's the honest outcome on a real site. Not everything gets fixed in the same week. What matters is that they're recorded with their reproduction steps, so whenever I do get to them, this same check runs again and tells me whether I actually succeeded. Now it's time to close the Jira tickets. Since the local report includes the reported Jira keys, it can finish the job. First, let's check the current status of these tickets. They're currently in ready for retest. Since the fixes have already been verified, these tickets can now be moved to done. Here's my prompt. Update the status of fixed Jira tickets to done. As always, it starts with a dry run and then updates the tickets in Jira. It also updates the ticket status in the original defect report, keeping everything in sync. Now, let's check the status of these tickets in Jira. All 3 tickets have been updated to done. And that's the defect lifecycle from start to finish. Found through an audit, filed with evidence, deduplicated, fixed, independently verified, and finally closed. All through plain English, with a complete trail that someone else can follow. And that's it. Snaggly is free and open source, and the link is in the description.
2 things to take away.
The first is that every fix in this video came from a finding I could verify myself. The tool didn't ask me to trust it. It showed me the evidence, and when I checked one, and it was wrong, that was easy to establish too. The second is that a tool like this earns its place in the verification step, not the finding step. Plenty of things can find problems. What's rare is something that will still be able to tell you 3 weeks later whether the fix actually worked. If you try it on your own site, I'd genuinely like to hear what it found, and especially what it got wrong. If you enjoyed this video, please like and subscribe for more real-world AI tips for software testers. Happy testing!